Hi everybody, this is Mrs. Costello. I'm doing the day 4 video in the rationals unit. Today we're doing complex fractions, which means we have a bunch of fractions in one fraction. And some of you guys are hearing that and going, I don't like this already. It's gonna be okay. To start off, let's go ahead and review. Number 1 is right there. It says to simplify. Why don't you go ahead and try to do the review on your own? So I'm going to have you pause your video and do the review now. Okay, here's my work on number 1. It might have stumped you at first, but remember that these guys are, I call them opposites, like they're opposite signs. And the way to change them into the same denominator is just to multiply by -1 on that first fraction. So I had -1 over x minus 1, and then you add it to x over x minus 1, and guess what? They're the exact same thing. So you should have gotten A as your answer. If I explained that differently than your teacher did or whoever made that video where we talked about the opposites did, please, ask your teacher about it tomorrow in class and they can totally explain it to you. All right, so today's complex fractions, there's only like 4 or 5 problems. It doesn't mean that they take a long time. There's just not really a whole lot to them. Our goal is to make one fraction on top, one fraction on the bottom, because then we can go ahead and divide fractions. So looking at number 1, I have one fraction on top. I have 8 over 5x. So the top looks good. The bottom, I have 2 fractions. Luckily, I have common denominators in the 15, so I can go ahead and add the x plus 1 and the 4. When I do that, the top stays the same. So I have 8 over 5x still over, see why it's complex, because there's a fraction on top and then it's one big fraction. Combine my like terms, 1 and 4 is 5. So I have x plus 5 over 15. Awesome. Now I have one fraction on top, one fraction on the bottom. I get to treat them like dividing fractions. So remember, when you divide your fractions, I say skip, flip, multiply. There's another one, and I can't remember it right now. I'm blanking on it. But we're going to leave the first fraction alone. So 8 over 5x. We flip the second one, and we're going to multiply. So my second one is now 15 over x plus 5. Now, you do want to cross-reduce if you can. And it looks like I can on this one, because I have 5x and 15. Those guys can both be divided by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. Now, if you go the other way, there's not really anything else. 8 and x plus 5 is good. So we're just going to multiply straight across and write as one fraction. So 8 times 3 is 24 over, you have x times x plus 5, which you might have to check with your teacher. I think it varies. I'm okay with this answer. Some of your teachers might want you to distribute, but I think this answer is fine. If you do have to distribute, you'll have 24 over x squared plus 5x. Okay. And the reason why I like leaving it simplified is that's going to be really handy on some of the other later days too. All right, same thing on number 2. So, same thing, our goal is to get one fraction on top, one fraction on the bottom, and then multiply them. On the top, I'm good. I have 2x over x plus 1. On the bottom, I have 1 over 3x plus 2 over x plus 1. I do not have common denominators, so I need to make common denominators. So 3x is the first denominator, and then x plus 1 is the second. Now, there's no way to turn the 3x into an x plus 1 or the x plus 1 into a 3x, so we do need to multiply them by each other. So my first fraction is going to get multiplied by x plus 1 over x plus 1. The second one's going to get multiplied by 3x over 3x, like that. Okay. The top is still the same, so leave it alone. So you have 2x over x plus 1, and then you have to be really careful on your second fraction. You might have to distribute. Luckily on this one, you just distribute a 1 on top, and that's not really a big deal. So you have x plus 1 over, again, I write this as the factored form, so 3x times x plus 1, because it gets really complicated if you start, distributing it out. But it is your teacher's preference as well, so I would ask them. And then 2 times 3x is 6x over, leave it again, 3x times x plus 1. Now we almost have one fraction on the bottom. On the bottom, we just need to combine the like terms, the x and the 6x, and then everything else should be good to go. I'm going to go ahead and write my work in the corner over here because I'm running out of room. So 2x over x plus 1 all over 7x plus 1 over, keep this factored, 3x times x plus 1. Now I'm in a place where I have my 2 fractions, so I'm going to go ahead and divide those fractions. So 2x over x plus 1, keep first fraction, skip, flip it, so 3x times x plus 1 all over 7x plus 1. Okay, if you look at this, this is a situation where you're going, okay, I'm really glad she didn't have me distribute out that 3x, because when you go to cross reduce, look what you have. The x plus 1s can cancel because you have an x plus 1 on the bottom and an x plus 1 on the top. Anytime one's on top, one's on the bottom, it can cancel. Now, here's a common mistake I see is a lot of you guys go, oh, there's x's on top and an x on the bottom, and you cross off the x's. You can't do that because this 7x plus 1 is closed by addition, so you can't just go like, oh, I'm going to get rid of the x there. It's not how it works. I'm sorry. If you had 7x plus 1 on top, you could do that. Okay. All right, multiply these dudes. So 2x and 3x, 6x squared over, and then there's nothing with the 7x plus 1, so you leave it alone. Okay, and that's going to be your answer on number 2. Hopefully not awful yet, but I know it's kind of early, so we'll see. Alrighty. I really think you guys could totally do number 3 on your own. So why don't you go ahead and pause your video and try number 3 on your own. Okay, here's my work on number 3. It was pretty easy to make one fraction on top, one fraction on the bottom because they already had common denominators, so not awful. So I got 5y over 4 all over 3y plus 8 over 2. I flipped them and flipped the second one and multiplied. I was able to cross reduce 2 and 4. Now the answer in blue, the 5y over 2 times 3y plus 8 is an answer I would accept. If your teacher wants you to distribute, you would have 5y over 6y plus 16. Again, do not cancel out those y's because the 6y, or the y's on the bottom are closed with addition, so you can't. Okay, we'll do number 4 together. Number 4 is kind of like the last one. You do need to make common denominators on top and bottom. The interesting part, there is a different way of doing this, and I kind of want to show you. No, I won't make it confusing. But if you want to see the other way of doing it, you can ask your teacher in class. Basically, I would clear out all of the denominators. And if you want to see it that way, that's great. If you have me, you can ask me about it in class tomorrow. If you have somebody else, you could also ask them about it. I'm just going to make common denominators to kind of keep it the same. And a lot of people prefer that anyways. So on top, I have 2x and x squared. And I can't really turn the... You have to kind of think about this because you can't turn the 2x into an x squared. You can't turn the x squared into a 2x. What you need is you need it to say, if you put them together, like technically the least common denominator would be you have 2x and then you have x squared. Could you make that 2x squared? And the answer is yes. Like all you're missing on the 2x is an 1x, and then all you're missing on the x squared is a 2. So take the shorter route. You do not have to multiply them by each other. So I'm going to multiply by x over x. And then the second fraction, I'm going to multiply by 2 over 2, because that's all that's missing when I'm making my least common denominator. So 5 times x is 5x over 2x squared plus 7 times 2 is 14 over 2x squared. Now on this one, the bottom ones are the exact same. So you're going to do the same thing. You're still going to get 2x squared as your common denominator. So your first fraction needs to be multiplied by 2 over 2, and your second fraction needs to be multiplied by x over x. So we have 2 times 3, which is 6 over 2x squared, minus x over 2x squared. Alrighty. So make go ahead and add those. Make one fraction on top, one fraction on the bottom, and you have common denominators, so it shouldn't be a problem. So 5x plus 14, we just write it like that. 5x plus 14 all over 2x squared. All over, because we haven't changed those complex fractions yet. 6 minus x over 2x squared. Now we can now we can go ahead and multiply them. And this is where doing it the other way might be a little bit easier, but I know I've taught it that way in the past and people have gotten confused. So you remember to flip your second fraction. So 2x squared over 6 minus x. Okay, if you go to cross reduce, you have 2x squared and 2x squared, one on top, one on bottom. That whole thing goes away. That's super nice. Now you can't, remember, the top and the bottom are closed under addition and subtraction. So unless you can factor out something in common and get 5x plus 14 or 6 minus x, you can't do anything. So 5x plus 14 over 6 minus x is going to be your answer on number 4. All right, now we have one more, and it is a multiple choice. Let me just kind of get rid of some work really quick. Okay, so it wants you to, simplify those complex fractions. So let's just focus on getting one fraction on top and one fraction on the bottom. Maybe we can eliminate and get the right answer. I don't know. We'll see. So the top is good. The bottom, let's go ahead and change those. So we have x plus 1 and we have 3. There's no way to change the x plus 1 into a 3 or the 3 into an x plus 1. So we do have to multiply them by each other. So times 3 over 3. And times x plus 1 over x plus 1. Okay. All right. So first, the top is totally fine. So you still have x minus 3 over 2. On the bottom, 3 times negative 4 is negative 12. Plus, you have to be really careful with your x. You do have to distribute it. So you have x squared plus x. All over, we made common denominators. 3 times x plus 1. Notice how I just kind of made it one fraction and I skipped showing that they're two fractions and I just said, hey, it's one fraction. You can do that. It's okay. All right. Ooh, this one's a little bit more challenging. That's fine. Okay. So we're in the place where we can go ahead and write that we can divide the fraction. So you're going to leave the first fraction alone. That's your skip. Flip the second one. So 3 times x plus 1 over. Now I'm going to write the second part in order. So it should say x squared plus x minus 12. Okay. All right. None of these look like my answer choices. None of them. Okay. And the reason why is on the bottom of your second fraction, you need to factor this guy. Okay. Now, this is a unit where it is a lot easier for easy trinomials if you don't set up the x. And I'm not going to. I know a lot of your other teachers aren't going to. They're just going to be like, listen, this is what it is factored. Okay? So, x squared plus x minus 12, two things that multiply to make negative 12 and add to make 1. Sorry, I just realized this looks like a fraction. It's not. My factors are going to be x plus 4 and x minus 3. Okay, see how I didn't set up the x? It's a lot faster. All right, so let's go ahead and cross off where we can. Looks like we have an x minus 3 on top and an x minus 3 on the bottom. We are allowed to do that because we factored out the x minus 3. That's allowed, okay? We can't do anything with that x plus 1 or that x plus 4, so we're going to leave it as 3 times x plus 1 over 2 times x plus 4, okay? Now, maybe my answer choices, I think, okay, so they did distribute on A, but if, like, you can see that. You guys have pretty good number sense, so I think you know, like, okay, if I distributed the 3, it would get me to this answer right here, A, which is 3x plus 3, over 2 times x plus 4. Sometimes they distribute and sometimes they don't. This is pulled off of like some instructional materials for final exam prep. So, all right, that's all I have for you on day 4. If you have any questions or you want to know like other ways of solving these, feel free to ask me or ask your teachers. Otherwise,